We've been hearing about AI for over 3 years, and each time the new technology comes, it is expected that it disrupts the sector or maybe the industry, but never to a scale where it disrupts multiple industries at a global scale. So far, SaaS companies have been valued around 3x to 5x its revenue, irrespective of what product or what problem they solve. That is the rough ballpark of their revenue to valuation ratio. But AI companies are 20x their revenue, and sometimes pre-revenue and sometimes no revenue at all. So, what is that one thing that fundamentally changed that has created this new world that we live in? I think to understand this better, I kind of wanted to talk about only the fundamentals. And AI for dummies, there's not going to be code, there's not going to be any kind of math or anything like that. Just complete fundamentals on what is an LLM, how it is being pre-trained, what is inference, and what are the business use cases, and maybe one or two case studies. But I want to talk only about from the business perspective of what an LLM does. It's maybe for product owners, product managers, technical, non-technical people, people who are starting off with AI, who are about to start companies, who are entrepreneurs, anything, pretty much the entire scale. But I want to talk about only the fundamentals of how it works. And once you understand that, I think the rest of the math and all of those can follow. You can use any kind of AI coded coding tools, AI did coding, and you can figure out the rest. I'll talk about only the fundamentals. Okay. Question: what is the next word? This is pretty much what the dumbed down version of what AI is that the one question the model keeps asking is that what is the next word? So that is the sole task. That's just exactly one job, which is not if the next word is right or not if the next word is true. What is the next one? If you keep doing this thousands of times and feeding each answer back in again and again and again, that is when you get essays, code, summaries, answers, so on and so forth. Right? So even though it might look complicated, it just does one single thing repeatedly. So let's take maybe an example and then look at how do you get something to guess the next word, right? And how do you kind of do this? This is basically what pre-training is. So let's get started. Let's take this example of the sequence, right? We all know that the next number is going to be 5 because we know that it's going to be incremented by 1, right? Now, if you take a look at this, AI doesn't know what 1, 2, 3, and what is a sequence, what numbers are. It doesn't know any of those things. So what it will kind of do here is that we give it 0 to 9 and we tell it that you can pick any number from 0 to 100 to 1000 to million to whatever. You can just pick a random number, and what do you think the next number is given the sequence, right? It can pick any number from 1 to infinity. So it picks 3, for example, right? And then you don't tell it the answer yet. You just tell it maybe just go higher. It has to be just more than 3. Then it picks 20. Then you tell it, you know what, you just have to go lower. And then you say 4. Then you say maybe just go little higher, right? And then it says 6. And then you do a little lower. And then it goes to 5. Now what happened here is that if it knew to find out a pattern and then do the math and then find out that it's just an increment of 1, you could have found that it's 5 way earlier. So it is not thinking to give you an accurate answer. It is not thinking to do a fact check. It is just trying to predict from a given set of numbers, and we are guiding it, telling it that are you right or you wrong. This is the only form of feedback it has. It has no feedback in terms of whether the numbers are instead of going to the depth, just the overall from a very creamish level. It doesn't understand what this means. If you say that 5 is right, 5 is right. If you tell it that maybe 3 is right after 4, it'll know 3 is right. That is where we garbage data comes in. But for now, if you have 1, 2, 3, and 4, the next one is 5. It doesn't know what 5 is, but it knows that given the sequence, it's 5. It'll remember this, right? Now let's take one more example here. we know it's 10, 15, 20, 15, 10, which is you just have to decrease, subtract 5 each time. And when you ask it to predict, it'll predict 40 because it doesn't understand the math here. And then it does the same thing over and over again, and then until it gets 5, and then you say that you're right. So it remembers that if you see a pattern, right? If you see it's like 20, 15, 10, it doesn't know what those numbers are. It understands that if you see these in a series, the number that usually follows next is a 5. And this is the second example. And if you do it maybe enough number of times, if you give it enough number of examples, pretty much all of those answers were 5, right? But each one had a different reason, but it doesn't remember the reasons. Okay, what it does is that it takes a note that given this sequence, I got 5. 5 is the same answer, but given the sequence, you add 1, you subtract 5, you divide it by 10, right? And what it does is that the same way when we told it, we give it a table and we say 0 to 9, and you have to pick from this, and you can maybe use multiple like 10, 20, 30, and but the base numbers are 0 to 9. And then what does is that it has a column called note, and it takes note that for 5, if this is the sequence, you have to add 1 and then 5 will be the next one, and then it will be the same thing for the second use case, third use case, and then it keeps doing it until maybe if you give it 1,000 examples of different ways where 5 comes in, right? Maybe 1,000, 10,000 times, and you do it for pretty much all the numbers, let's say 0 to 9. Now it doesn't know what the numbers are, but it knows what comes given this is what is about to follow. And now if you tell it what it is, it'll get it right on the first try. It'll know the pattern exactly because it has been trained on the correct use case, on where what the next number will be, because it has seen so many examples of doing so. So once you keep showing these numbers to it, it kind of tunes itself, right? It kind of tunes, or maybe if it has like 1,000 knobs and each one of those knobs learns, let's say for example you're trying to pick 10, you need to pick 10, and let's say you try to pick 10 and then you stop at 5. You're supposed to stop at 10, but you stop at 5. So you learn that maybe you're a bit too early, right? And the next time you do that, you stop, you just give it enough time, and then you stop it at 8.6 seconds. And then next time you do it, you stop at 9.87. So you see what you're trying to do is that you're trying to get as close to 10. Usually in an LLM, it doesn't usually hit at 10. There's no perfect answer. There's usually the probability is higher, but not perfect. Most of the use case, right? So what it's trying to do is it is trying to learn this. This is the thing that it's trying to learn during pre-training. It's trying to get to a 10. From 0, it's trying to get to a 10. So every time it goes from 0 to 1 to 3 to, and then it keeps fluctuating. Sometimes it goes over 10. And but most of the use case, if you use gradient descent, so most of the time, it is trying to get as close to 10 as possible. Okay. Now, once it gets close enough, and you know that it's pretty close, that is when you stop training it. You know it's good. You know that most of the time it's able to get really, really close to 10. Our goal is not to hit 10, and trying to go as close as possible to 10, because most of it cannot validate. So we don't know if we cannot have a 100% use case. So it's mostly like if it's a 9.87, it's pretty good. There are a couple of benchmarks that industry standard benchmarks that talk about how do you evaluate LLMs and stuff like that. But on a general use case, you're trying to get as close to 10 as possible. Okay? Now, once you come close, you just stop adjusting. That's it. You leave the knobs where they are. Okay, we'll talk about knobs in a bit, but what you're trying to do is that it's the muscle memory that it's trying to build. When you know when to stop so that you get as close to 10 as possible. Right? Now, once these are done, these are trained models. These will have frozen data, but these are basically trained model. They'll know what the next number is, what the next word is, based on given the multiple data that it's being trained on. It'll know what the next one is. No, just took 3 use cases and we were doing it, but we are going to train on trillions and trillions of data, right? And when you're training on a huge data set like the internet, you cannot just play higher lower with it, right? So what happens here is that you will have it'll basically guess for something, and then you will tell it whether it's right or not. This is basically automated. And when you keep doing this enough number of times, it will get to the number where we get to 9, how we got to 9. Now, let's talk about the knob and how this knob works. An example of the knob, right? And it's not just one of those knobs, it has like billions of knobs. Okay, and these billions of knobs that are has to be at the right setting, to put it bluntly, to get to the best answer and plausibilistic answer as possible. Okay, we're trying to get a plausibility. Now, let's take, for example, the same table, but maybe let's do it for words now, right? We did for numbers, now we'll take it for words. Now, if you take, for example, the lion is the king of, we know what the answer is, but we have just given it previously, we've just given it a bunch of words here, and we have not given it any note about what those words mean or anything like that. So it just randomly picks, maybe it's kitchen. It's random, it just randomly picks it, right? And then we tell it, no, it's wrong. We tell it that the correct word is maybe the jungle, right? And the way you kind of nudge it is that you're trying to get the levels right just before a meeting. Let's say you're doing a meeting and then you're saying that you're setting your volume to maybe 62. That's like the perfect volume that you have. And then the brightness of your screen and your microphone. And then this is not just random numbers. These are the numbers that you set that is right for you, right? And this is the reason why when you do AI, enterprise AI and stuff like that, these are completely different from frontier models to your own trained models and the ones that are open source. So all of these numbers are different because you're trying to train it for a different reason, for different use case, right? So here the thing is that it is not that you're trying to get it correct, right? There is something for different for everyone. What we're trying to do here is, what is the correct number that you want to set your volume, brightness and microphone to, so that you have a more the meeting goes perfectly as you want it to be, right? So setting it maybe at volume at 50 and brightness, more high brightness, low microphone might be different for somebody else, but for a general use case, this is the default, the one that it's being trained on. That is perfect. That's just perfect numbers, right? Now, let's take a look at the same example. Now, once you set it to that right number, it will know that the next word is jungle, right? The lion is the king of the jungle, okay? And nobody basically told it what a jungle is or what a forest is or anything like that. Given the training data, it said that most of the time, and it's being trained saying that the rest of the words don't is probabilistically not the right answer, and this is most of the use case, this is the right answer. That is why it picks jungle. It doesn't know what a jungle means, right? Now, the same thing, let's take maybe of the word for lion, right? It never learns what a lion is. It doesn't know what it is. It doesn't know what it does, right? Now, the only way that it kind of knows what it is that it's a reference to the others. Let's say, for example, who are you, right? You are maybe the son and daughter of somebody, and your relation with somebody tells who you are as a reference to most of the people, right? And your position at a company. So it's more in terms of your relevance to something else. Gives more meaning to who you are, right? So similarly, for example, for a lion, it knows that it's part of the animal kingdom. It's a predator. It's a cat. It doesn't know what lion means, like that lion as an animal itself. It knows that these are relevant to lion is what how it kind of identifies lion. Lion is it's something like it says if you're trying to explain something to somebody, but you don't know what the word is, and you say something that is close to it so that they try to understand it better. So you say maybe it's a lion and it's a predator. It's also a cat and it's in the wild and it's usually referred to in the royalty. And there's also a movie about it, right? So this is how it knows what a lion is. It doesn't know lion as it is. Okay. Now, if you take a look at the same thing, right? In two different, just how the five applied to multiple use cases, the same way, the lion in different use case, it's also a movie and it's also an animal, right? For both the two use cases, the context of what was there before this, it only tells you what comes after, right? So be it like five or be it whatever the word, number, whatever it is, it doesn't understand what it means. It understands its meaning to its context, what came before it, and then what should come after. That is how it knows whether this word is probabilistically right here or not. Now, if you take, for example, the same thing, the one you did for numbers, if you do the same thing for words, saying that most of these words, this is the reference to which it is, right? If you take a look at these nodes, to go just one layer deep, these nodes are vectors. Vectors are basically things that describe the word for the computer. We know that these are the things. We don't know what a random number that a vector picks. A vector is basically a note for the computer. It doesn't have to because it doesn't understand words. It understands numbers, and we don't understand what those vectors actually mean. So this is an example of how we take notes, and the same thing it will take notes in numbers. So those are called vectors, and each note within for a single word, those are called dimensions. That is what dimension is for each one of those vectors. So that's a vector and dimension. But again, to come back to this, the overall of it, there's a word, and then it takes a note of what it is. So whenever there's a sequence of words that it sees, it will come back and reference to these note, basically the vector, the note, and it sees that usually if this is the use case, what is the word that I have to pick? And it picks a bunch of them and see that maybe 98% of the time this was used, or 95% of the time this was used, and then it uses that word. So that is pretty much what this table does. So this is the table that pre-training kind of leads to. This is the goal of pre-training. We're trying to create this table. So if you're trying to train an LLM, we're trying to tell it that there are a bunch of words, and for each word is used for different use case based on that use case, and we give it a bunch of use cases. And when I mean a bunch, trillions of it. And then we tell it, you kind of train yourself to have a muscle memory, basically, and figure out what word should come next. The muscle memory is the one that we spoke about, where we want to get to the 10 seconds, right? We're not trying to hit the 10, but we're trying to get as close to hitting the 10 as possible, right? So once this is done, the rest of it is just delivering and customizing and adding, to say maybe more, adding a personality to this. This is the skill. We're training an LLM with trillions of words and trillions of data that, given the sequence, without a sequence, it cannot predict the next word. Take it any LLM, any chat, or most of the use cases, you have to have a sequence, and it doesn't know it's chatting with you. It doesn't know it's a question or it's an answer. It doesn't know any of those things. The only thing that it's trying to do is what is the next word. And this is the whole part of the training. There is another section that happens as part of this training, is that it learns the grammar as a side effect. It's explicitly trained to some extent, but it's not the main goal. As a side effect, the grammar also gets trained. So the first thing it'll get right is the grammar, more than the word itself. It'll be grammar. First, it'll be gibberish. The second thing it gets right is the grammar, and then the words, sentences, paragraphs, all of this kind of makes sense. Now, if you take a look at the other section of this training, is that what is the next word is one part of the question that it's trained on. The second is this the last word? This is where whenever you chat in LLM, in chat GPT, Claude, Gemini, whatever, right? Each one of them, how does it know when to stop, right? It is also trained on that here. Usually given this sequence, this is what happens. This is the next words that follow. And after these words follow, and then they just stop it. So it also gets trained on when to start and stop during pre-training. So to summarize pre-training, what we fundamentally do here is that we give the LLM a bunch of words, pretty much everything, and we tell it, take your own notes. We're not going to tell you what this means or anything like that. Take your own notes. In reference to this, what does that mean? If this comes, what does it mean? If that comes, what does it mean? So basically, we don't tell it that this is what it is. If we do it very, it's going to be pretty much static data, and it will not, it cannot predict given a new use case. If you give it something new, it will not be able to predict what the next word is. So we're trying to give it a bunch of words, and then we're trying to ask it to take its own notes, and that is the note part. And if the one more layer deeper here is, each word becomes, basically it's called a token, and each note, that is a vector, and each vector has multiple numbers that represent what the word means in reference to others, or different dimensions, keeping it very on a very high level. Those are basically characteristics of the word. different ways that it understands what the word is. And the more notes it takes, the number of notes is our dimensions. Usually it's about 6,000 to 12,000 dimensions given which frontier LLM model that you use. So it's about from 6,000 to 16,000, and usually they don't disclose what that is, but it's around those numbers. So once you get this right, you just stop training it, and then this is frozen in time. So it will not have any other data. That's where tools and all of those other things come. And we'll maybe talk about that later. But this is pretty much what pre-training is.